Dear students, it is my third video for syllabus of class 9th. So within moments I am recalling you back starting from first that in my first video we had made a discussion about matter in our surrounding. What matter is, from which it is made up of, what are its constituents and all this. After that, in my second video, what you people had seen that we had studied about the properties, important characteristics of small particles which are the maker of states of matter available in our society. Correct? And on the basis of all those knowledge which are now placed in our brain, we are in a position to make a further study in this regard. And in connection with that, now I am going to, today in this video, I am going to discuss with you about states of matter. About states of matter. One thing, point to be noted. This word is very much common. States doesn't here stands for Bihar, Bengal, Odisha, and all these. Here states have the physical meaning, physical condition of the matter. Correct? So, students, the constituents of the matter which is too small, suppose they are lying far apart. What it means? That distance is extremely large, but it is also parallelly showing that the force of attraction between them is less. That's why they are lying far apart. Correct? So here generally books used what term? Intermolecular distance and intermolecular force of attraction. Both are related with each other and they are reciprocal of each other. Students, if intermolecular force of attraction it is greater, it is intermolecular force of attraction is less, then intermolecular distance is maximum. And matter has which state? Gaseous state. And by any means, if this force of attraction becomes greater, it increases to some extent. What happens? Causes decrease in distance. And then the states of matter it is called liquid. After that, suppose the constituents are coming as close as it is possible. Then what happens? It indicates about maximum intermolecular force of attraction, and then it is solid. So mainly there are three states of matter: solid, liquid and gas. Solid, liquid and gas. So all the three in here it is point to be noted. You may see in the books also in different literatures two more states of matter. By the name they come. Here is Bose-Einstein condensate and here is plasma. But these two means at a very low temperature and at a very high temperature, those states of matter are existing nowadays also. They have their existence, but they don't have means practical utility is less. Correct? So, for practical utility which is used by we people while interacting in our day-to-day life, it is only three. And which are the only three? Solid, liquid, and gas. What are the yardstick which determine these? It is two. Number one is intermolecular force of attraction. Number two is intermolecular distance. Correct? So on the basis of that, we have this popular three states of matter. We will discuss it one by one. First, come to solid state. First is solid state. Students, repeatedly I am telling, it is intermolecular distance minimum and intermolecular force of attraction maximum. And the solid state of matter, just the chalk in my hand, it is also solid. So what you see, that it has a fixed volume. Solid has fixed volume. Number two, fixed shape. Correct? Minimum compressibility. Minimum compressibility. Here, this new word compressibility, let us try to have a discussion on it. Actually, when we just press the matter and its volume changes, then this property is called compressibility. So, solid have negligible compressibility. Its volume almost remains constant. It has, therefore, have mass, volume, and hence density, all these things. Correct? So they have, means solid have fixed volume, same minimum compressibility, it has mass. This one I have repeated just to explain to you people about density. That's why I have used this one, and just close to each other. That is mass and volume. What they are? They are the determining factor for the density, which is a property of matter. Correct? It is what really? It is mass per unit volume. Mass per unit volume. It is density. So all such features, they are present, and it is at room temperature. Then when we will heat it, then what happens? The solid gets heat energy, and when heat energy is given, what happens? The constituents have thrilling in them. And what they do? Just they dislocate in respect of their own position, as a result of which we call the thing it is boiling. So melting. So melting point fixed means that suppose iron. So if you are taking iron on heating, it will melt at a particular temperature. Suppose my friend is doing the same work, but there will be no variation in temperature. Means only at that temperature solid will melt. Suppose I am doing this experiment in MP, then it is the value of melting point. And if I am doing this one in UP, Bihar and other places, same melting point. What it means? Melting point of solid is also fixed. So these are the features by which a matter can be characterized, and what is that? It is known as water solid states of matter. After that, come to second. Second is liquid. Next is liquid state. No doubt, liquid state have also fixed volume, but no fixed shape. No fixed shape. What it means? It means that liquid adopts the shape in which it is kept. Suppose you take some water and just that glass of water you have taken in a bowl, then it will have the shape like bowl. Now convert that same amount of water in glass, then what will happen? That water will have then shape of glass. After that, you are transferring that one in a plate, then the same water will have the shape like plate. So what we call no fixed shape. And here it has intermediate compressibility. Liquids have intermediate compressibility, means not less like solid and not more like gas, but in between that. And that's why it is called intermediate compressibility. And what is compressibility? Again I am repeating, it is change of volume by applying pressure. Correct? Then every liquid has got mass. Every liquid has got mass. It has got volume. fixed volume. Correct? Then mass upon volume, it will be density. Correct? And when you take any liquid and you boil it, you heat it, what will happen? There will be a particular time at which boiling of liquid will start, and that is known as boiling point. So it has fixed boiling point. It has fixed boiling point, means boiling point of one liquid is not equal to boiling point of other liquid. As for example, you take water, you heat it. The moment you are heating water, what will happen? After some time, when the temperature of that amount of water will become equal to 100 degrees centigrade, it will start boiling. Correct? Before this temperature, it will only evaporate, but it will not boil. It will evaporate only, but it will not boil. But at 100 degrees centigrade, it starts boiling. So it has a fixed boiling point, means water at every condition boils at this one. Next is take ethanol. Ethanol is also a liquid, but that liquid will boil at 46 degrees centigrade. Correct? So that's why they have a fixed boiling point. After that, now come to third state of matter, and it is gaseous state. Gaseous state. So gaseous state is characterized by no fixed volume. No fixed volume. Second, no fixed shape. Both are changing, volume as well as shape. Then, in case of gas, it will have maximum compressibility. It will have maximum compressibility, and gas has mass, volume, density, and so they are the features related with gaseous states of matter. So, dear student, just in respect of that, I am sure you will have perfect idea of these states of matter. Just after that, going to discuss with a continued topic, can matter change its state? Can matter change its state. This is the topic. Just we came to know there are three states of matter: solid, liquid and gas. Now we are trying to know, can such states of matter which we are interacting frequently, are they capable to change their state? Its answer is yes. Answer is yes. What it mean? It means matter can change its state. So now we have to know how it is possible. What are the physical factors which are responsible for change of states of matter? Dear students, first is temperature. First is temperature. Actually, different matters are scattered in our surrounding. Then, at a time, you touch one matter, no sensation. You touch next matter, you are feeling hot. You touch next matter, you are feeling cold. You are the same. But when you are touching different matters, some matters give you cold sensation, someone giving hot sensation. Correct? The physical reason behind such type of feeling to be inculcated in our body, it is known as temperature. Temperature is the physical region which provides us such type of distinguished situation when we interact with different matters. Correct? So, it is temperature. Again, I am coming to the point. What is temperature? Temperature is a physical region which is responsible for giving us sometimes hot situation, sometimes cold situation. So in this way we came to know about temperature. So some on touching, someone is hot, someone is hotter, someone is hottest, someone is cold, someone is colder and someone is coldest. What it means there is a need for measurement of temperature, and right from very beginning these matter were studied, just measured by three different measuring scale. It was Fahrenheit, centigrade and Romer. Fahrenheit represented by F, centigrade and Romer. Fahrenheit, centigrade and Romer. They are interconnected with the formula F minus 32 upon 9 is equal to C upon 5, C is equal to R upon 4. So, this is the previous one, but now one more is available and it is Kelvin. It is Kelvin, represented by K or capital T, and it is used with centigrade. Centigrade measured in degree and represented by a small t. So, in the syllabus of class 9, there is there is frequent interconversion of the two temperatures of centigrade and Kelvin, and it is related with the formula K is equal to C plus 273. This is in Kelvin and this is in centigrade. Kelvin and centigrade. So, if one temperature is given in one form, we can easily convert into another form. As for example, convert 43 degrees centigrade into Kelvin. It will be E equal to 43 plus 273. It will be 6 316 Kelvin. Next, convert 200 Kelvin into centigrade. Then it will be 200 equal to C plus 273. It will be C will be equal to 200 minus 273. It will be minus 73 degree centigrade, like this. So you can easily convert centigrade into Kelvin, Kelvin into centigrade. So what really happens that you take solid, you heat it. After some time, the solid will convert into liquid. You continue heating, liquid will convert into vapor. Again, you cool it, vapor will convert into liquid, and again cool it, liquid will convert into solid. So such type of trend is experienced, which you can write as solid heat liquid, liquid heat vapor, vapor cool liquid, liquid cool solid. So such type of symbolic representation, in a nutshell, it can be given for matter changing its state, and change in states of matter, it is carried out when a second physical factor is keeping constant. Means when we are doing all these in a lab, then what is happening? In that lab, atmospheric pressure is constant. So it is done, means such type of tendency trend is visible under what condition? Condition is at constant pressure. It is done at constant pressure. So what we had seen, students, matter can change state, and how we have considered today only one physical factor which is responsible for changing states of matter. So only up to this in this video. Thank you all.